Hello, everyone. In this lesson, I like to record a lesson on integration by substitution for definite integral, and especially on how to show words. Okay, because there has been, in the past when I was teaching this class, there has been a lot of confusion or inadequate words found. And as we get closer to the semester, we don't have a whole lot of time. So I hope that I will give you enough practice time and space so you'll learn how to show work and also master this technique of integration by substitution. Okay, and we understand to evaluate the definite integral like this, we use fundamental theorem of calculus part 2. But as far as how to show work, there are multiple ways to do that. The first way, and then you could have the option to show work in any way you want, but it has to be appropriate. Okay. So I'm going to show you, and here are all the homework questions, and I use the same homework number. So it makes it easier for you to find out, and so you can compare your work with the answers or steps. Okay, so let's start from 59. Apparently, this is a definite integral. Okay. So let's put up a solution here. Okay, it's obvious that we're going to show. We're going to find the area that substitution is going to be u equals to pi times t divided by 2, and the du will be equals to pi over 2 dt. Okay, so we're not only going to substitute. Okay, we are also going to substitute with respect to the new variable u, the lower limit and upper limit. So for that, we will need to make a table. Okay, so this is how the table will look like. Okay, so I'm gonna make a table. Let's see. That should be enough. Okay, so there's a t and there's a u. Okay, and u is equals to pi over 2 times t. Okay, so t runs from 0 to 1, and u accordingly will get values. So when t equals 0, this t will be replaced by 0, and this will be 0. Okay, when t equals to 1, u would equal to pi t divided by 2, t replaced by 1. So it's pi over 2. Okay, we don't need this last column anymore. So when we are doing the substitution, right, we're going to be doing the following work. All right, and all of these has to be done in one step. Okay, so take your time. First of all, right, so we have this definite integral notation. Okay, now we got a cosine u. dt will be replaced. Okay, dt will be replaced and solved for from here as needed. dt equals to 2 over pi du. Okay, so we multiply both sides by 2 over pi, the reciprocal of pi over 2. So that's how we get dt. So cosine pi t over 2, pi t over 2 is u, and dt will be substituted by 2 over pi du. So it's completely substituted, okay, for the integrand. And how about the limit? The limit, you cannot keep it at 0. If you do, you're going to lose points. So the limit is going to be also changed. That's going to be the limit for u, okay? So when t equals 0, u equals to 0. When t equals to 1, u equals to pi over 2. Okay, so that's the substitution. So you can see in comparison with indefinite integral, we have an extra layer of substitution. All right, so now we can continue. Okay, 2 over pi is a constant. We can move it outside. Okay, and cosine u du, and the antiderivative of cosine u is sine u. Okay, so sine of u is the antiderivative. But we're going to apply fundamental theorem of calculus part 2, right? We're going to apply this theorem. So, and we're going to express it this way. Bar, okay, lower limit is 0, upper limit is pi over 2. Right there. This is the same as pi over 2 as a constant. I'm going to leave it out. Bracket. Okay, so on this part, we're going to substitute u by pi over 2, subtract sine of 0. So we got sine, oops, sorry about that. Okay, so sine u, lower limit 0, upper limit pi over 2. Okay, so on this step, on this part, we're going to show it in the bracket. That's going to be sine of pi over 2 subtracting sine of 0. And that is the same as capital F of B minus capital F of A, as in the 0. Okay. Sine 0 equals 0. Sine pi over 2 equals 1. So the final answer is just going to be 2 over pi multiply sine pi over 2 is 1. 1 minus 0. So the final answer, oops, the final answer will be pi over 2. Okay, so that's one way to show work. That's one way to show work. When you show your work on your paper, okay, I would like to show you a way to lay out. Okay, I'd like to show you a way to lay out because we have the substitution part, right? So on substitution part, right, what you can do is that you can take this piece, okay, and okay, you can lay this piece side by side. Okay, so you can lay this piece. Okay, so this is your work. Okay, with substitution, and your U part is shown on the other half of the paper. You can show it that way. So this is one way to show work. Okay, another way to show work. Another way to show work is to follow the fundamental theorem of calculus part 2 more closely. What do I mean by that is that I'm going to take this part and integrate to find the indefinite integral. So we just want to find the antiderivative. How many antiderivative do we need? We only need one, because capital F in the theorem is just, it's any antiderivative of F. So we're going to find that antiderivative. And to do this, and of course, we're going to do substitution. And we don't need a table. We don't need a table. Okay. So another way to show work is that you show it this way. And then you are going to find the indefinite integral. All right. So you get, so this is u, right? And dt will be replaced by 2 over pi, right? du, and 2 over pi, we can place it outside. Okay. Then we got our antiderivative, 2 over pi, sine of u, okay, plus a constant. And then to finish it, right, you'll just replace u by pi t over 2, and you're done with the indefinite integral. And then we have, you have found all the possible antiderivative already. So you're going to just choose one. You're going to choose one. This one you choose is just one without the constant. Because in the theorem, it says you just need one antiderivative. So this is the antiderivative you will need. And looking at what we wanted, right? Looking at what we wanted, which is here, we have the antiderivative. So all we have to do is that we're going to do capital F, evaluate at 1, subtracting capital F, evaluate at 0. And you, to find this, right, to find this, you can write it down as capital F. Okay, you don't need to write both. Capital F, bar, right? Lower limit 0, upper limit 1. So you will have, just plug in, right? So pi over 2, you leave it out. And in the bracket, right, you have sine pi t, where t is substituted by 1. And the other one, t is substituted by 0, just like that. Okay, so this is capital F of B minus capital F of A. So this is another way to show work. Of course, in the end, we're getting the same answer. We're getting the same answer. Okay, you can line them up. Okay, like this. Right? So this way of showing work, but do not mix it up. Do not mix it. Okay. You just find your antiderivative, you use your antiderivative, and then you just, apply the fundamental theorem of calculus part 2. Okay, so this is another way to show work. Okay, these are the 2 major ways of showing work. And there could be some other variations. But one thing is certain, when you are looking for antiderivative, you just look for antiderivative. You can see in the second case, you don't need to work out the table, okay, because you don't do this substitution. So these are the 2 ways to show work. These are 2 ways to show work. Okay, so the first way, okay, so let me show it so you can see the whole thing. The first way to show work, right? The first way to show work like this and the second way to show another way. So these are two major ways, okay? In the following questions, then I will be showing you one of the ways, unless there's absolute necessity to show both, okay? So let's look at number 60. Let's look at number 60. Okay, I'm going to show the first way because the first way tends to be the harder one. So, and this is a more, I think it's a good practice for you to improve your algebra. Okay. Now for this case, okay, we will introduce u equals to 3t minus 1. Okay. U equals to 3 times dt. And then we will need to work out this table. Right? We need just 2 columns. So I have t and u. Okay. T runs from 0 to 1. And u is equals to 3t minus 1. So we're going to plug in, right? So when t equals 0, u equals to -1. When t equals to 1, u equals to 2. Okay, so we have the limit, lower limit, upper limit. Okay, and then we're going to carry out the substitution. And that equals to, okay, the integration. And this is going to be u raised to the power of 50 dt. dt is 1/3. dt is 1/3 of du. dt will be replaced by 1/3 of du. And the limit, you're going to have -1 to +2. Okay. A common mistake. Okay, I do want to point out the common mistake. A common mistake is that you have this almost done, but you forgot to change the upper limit and lower limit. And that will be a mistake. That will be a mistake. Okay. And if you change it to the next step, and that you make another mistake. Okay. Some people change it on the next step. Okay, some people change it on the next step. All right. Why is that a mistake? Why is that a mistake? The first one is a mistake because you changed the variable to q. You did not change the lower limit and upper limit. Right? This should have been changed. And here you change the lower limit and the upper limit without changing anything inside the integrand. So you made a double the mistake. So this kind of mistake, okay, this kind of mistake is that this is a mistake and this is a mistake. Okay, so you're gonna lose points. You're gonna lose points. All right. So without further ado, so avoid this kind of mistake. So when you're doing it, take your time and make sure every part needs to be changed. You change them. Okay, so I'm going to move this one right here. Then we're just going to finish it. All right, so equals to 1/3. And the antiderivative of u to the power 50 is 1/51. So that's u raised to the power of 51. And evaluate at limit of -1 and limit of 2. That's how you write it. Okay. And the next step, you have 3 times 51. And that's gonna be 3 times 51. 3, right? 153. And u raised to the power of, so you basically have this. Okay, I'm gonna show you. So you plug in u with 2 raised to the power of 51, subtracting -1 raised to the power of 51. Okay, so you just do the substitution, applying fundamental theorem of calculus part 2, that is. Okay, we basically apply this theorem. We apply this theorem. -1 raised to the power -1 raised to the power 51. 51 is odd number, so, and that is still going to be a negative, that's still going to be a -1, right? So this is going to be -1. -1 subtracted from 1, so that's going to be a +1. Then you say, well, do I need to simplify? Excuse me, do I need to write 2 to the power 51 as a number? No, just leave it like that. Just leave it like that. Oops, sorry. Parentheses will work. And the next one, 61. 61. Okay. Root, right? This is the root related question again. And it's pretty much clear as how we're going to substitute. So u is going to be equals to 1 plus 7x. Okay. And du equals to 7 times dx. And dx, of course, equals to 1/7. 1/7 du. And we make the table, right? X, u, x equals to 0 to 1. U would be when x equals to 1, u equals, x equals 0, u equals to 1. When x equals to 1, u equals to 8. Okay, so we're going to do substitution. While we're doing substitution, please, for this next step, you take your time. You take your time. Don't try to write too quickly, okay, which was a common mistake. Because in this part, you need to change 3 things. Okay, so let me show you what need to be changed. You need to change 3 things. The first thing is this is going to be written in terms of u, integrand, u. And dx need to be changed in terms of du. So this part, so dx is replaced by du. Okay, and the upper limit and lower limit. So you need to do 1, 2, 3. So 1 to 8. Okay, so 1, 2, 3, all 3. Okay, 1, 2, 3. 3 changes. 3 changes. If any part that's not changed, then there's a reason to take points off. There's a reason to take points off. Okay, and this part is completely x, and this part is completely u, with this interval transformed function change in terms of u, and dx change to du. Okay, so be very, very careful. Okay, be very, very careful. Equals to, okay, so next is going to be some simplifying, right? So this is, more or less usually there's not too much issue, okay? But just make sure you do it. You take your time and do it properly. Okay? Power rule. Okay, 1/7. Power rule, right? 1/3 plus 1. And u raised to the power of 4/3. 4/3. Right? 1/3 plus 1 is 4/3. And this is under 1. Of course, you can reduce it because this is 4/3, so this is going to be 4/3. Right? Evaluate it. So we're using fundamental theorem of calculus part 2. Lower limit is 1, upper limit is 8. You just take your time. Your work is actually doesn't have to be too long. Okay? Just take your time. You do the 1, 2, 3. 1, 2, 3. Or whatever in any order. So next step, we 1 times 3 is 3. 4 times 7 is 28. And u to the power 4/3, we're going to substitute. Okay, so u to the power 4/3 minus, and the first one, u will be replaced by 8. The second one, u will be replaced by 1. So capital F of B minus capital F of A. So we're quoting fundamental theorem of calculus part 2. Okay, and the rest is just simplifying. Simplifying, this is 1. And 8 is equal to 2 to the power of 3. Okay, 2 to the power of 3. Hold on. 2 to the power of 3. Okay, let me write it this way. 2 to the power of 3, and then power 4/3, and that's going to make 2 to the power of 4. 2 to the power of 4, so this is going to be 2 to the power of 4. And that's 16. 16 minus 1. Okay, so the rest is just arithmetic. Just arithmetic. So this makes 15. Reduce it. Can we reduce it? So it's 45/28. Okay, that's it. Okay, so remember this step of substitution. 1, 2, 3. Okay, use your scratch paper as needed. Okay. All right, 63. 63. All right. Solution. Okay. We know that the antiderivative of cosecant squared is negative cotangent, right? So our substitution is just, we have to make sure, oh wait, so this should be dt, sorry, this should be dt. dt2, let me double check, I think it should be a dt. dt, yep, dt. All right, and we have the interval from pi/3 to 2pi/3, right? So let's get started. Let's get started. So we're going to introduce a u. U equals to d/2. Okay, and du equals to half dt. Okay, or dt is twice of du. Twice of du. Okay, so we put this over here, and the interval changed. The interval change. Okay, so there's a t, there's a u. Okay, and t change from pi over 3 to 2 pi over 3. Pi over 3 to 2 pi over 3. And the u will be evaluated accordingly. So when t equals pi over 3, we're going to replace the t by pi over 3. And that's pi over 6. Okay, so that's pi over 6. And u equals to t over 2. When t equals to 2 pi over 3, we're going to replace the t by 2 pi over 3. So now we got pi over 3 there. Okay, because this 2 and this 2 reduced. So we have finished the necessary elements of substitution. So the rest we're just going to put it together. So let's do the 1, 2, 3. Okay, so let's do the 1, 2, 3. You can do it in different order if you want. And so when when t equals to pi over 3, u equals to pi over 6. So you can do 1, 2, 3 in different order if you wish. And the next one is pi over 3, right? So the one of the 3 is done. And cosecant squared of u, right? And dt. dt will be replaced by 2 times du. So dt will be replaced by 2 times du. We can bring the 2 to the front. Oh, done. When you think you're done, sit back and look if you get all of it is t and all of it is u. Okay, you should not have t and u all mixed up. Okay, and then let's continue. Continue, the antiderivative of cosecant squared is negative cotangent of u. Okay, and evaluate at pi over 6. Upper limit pi over 3. I actually wish this bar can be a bit longer, a bit taller. But anyway, it works so far. Okay, so I'm gonna combine this negative sign with 2, so negative 2. Okay, and only for cotangent u part, I'm gonna substitute pi over 3 and pi over 6. So cotangent pi over 3, subtracting cotangent pi over 6. So these two numbers will be substituted into place. Pi over 6. Oh, wait, one is pi over 3, one is pi over 6. Okay, make sure we got it right. And the next step, of course, we're gonna wrap it up. Cotangent pi over 3, okay? Cotangent pi over 3, what does that equal to? Trigonometry. If you don't remember, right, look it up. Cotangent pi over 3 is cosine pi over 3. Suppose we forgot. And the sine pi over 3. Okay? Subtracting cotangent pi over 6, right? So pi over 6. So we do need a couple values. You can use ART, DRA, or this is obviously ART. Cosine pi over 3 is half. Sine pi over 3 is root 3 over 2. Root 3 over 2. okay? And so this whole part is 1 over root 3. Okay, so this whole part is 1 over root 3. Okay, and this piece, cosine pi over 6, okay, sine pi over 6 is half. Cosine pi over 6 is root 3 over 2. Okay? And so this piece reduced is really going to be root 3. Okay, so that's root 3. Okay? And these are basic arithmetic. Okay, so we're going to make a common denominator. Okay, oops, sorry. That should be root 3 and root 3 squared. Because we're making common denominator. And then what do we get in the end? Root 3 squared is 3, right? So 1 minus 3. So near the end, so that's going to be a negative 2, right? So that's going to be a positive 4. Positive 4 over root 3. Done. Okay. All right. 53. Okay. 53, we're going to have some significant substitution here. As we're going to introduce u, right? We're going to introduce u equals to cosine t, right? du equals to negative sine t dt. And we got sine t dt, that's going to be negative d, right? So from here, you can see you need sine t dt, that's going to be equals to negative du. And next table, right? So we got t, we got u equals to cosine t. T runs from 0 to pi over 6, right? And u will run from when t equals 0, cosine 0 equals to 1. When t equals to pi over 6, right? Cosine pi over 6 is root 3 over 2. Okay? And now we're ready to do the 1, 2, 3. 1, 2, 3. Right? So let's do 1, 2, 3. 1, 2, 3. So we're going to have a lower limit, upper limit changed. Okay, when t equals 0, u equals to 1. So this will be for u. When t equals pi over 6, and u would be equals to root 3 over 2. Okay, and the inside, right, cosine squared t, that's going to be u squared in the denominator. And sine t dt equals to negative du. So this is the negative du, right? 1, 2, 3, 1, 2, 3. And the antiderivative of negative 1 over u squared is 1 over u. You can use the power rule if you want and substitute, right, capital F A minus a capital F of B. So root 3 Oh, sorry, that's 1. And the upper limit is √3. Okay, so substitution. So 1 over u minus 1 over u. So the top one, substitute this u, the bottom one, substitute this u, equals to, this is just u1, right? And the first one is going to be 2 over √3 minus 1. Do you need to do further? Excuse me. I think this is fine because you're gonna have something with roots there anyway. Do not, where it's not necessary to find a, to get a calculator to get a decimal number. Okay, just remember, most of your professors, they prefer precise answer. Okay, there's no need for calculator. There's no need for calculator. All right, 64. Okay, 64. 64, we'll have to introduce a u for sure, right? So we're going to introduce u equals to, I'm going to take 2 plus √x as my u. So the u would be equals to 1 over 2 times √x dx. Okay, because the derivative of √x is 1 over 2 times √x. And you can see there's dx is a √x, right? So dx over √x. So from here, you can get dx over √x, right? And that is going to be equals to 2 times du. Well, we will need that substitution. And the next substitution will be the table. Okay, we got x, we got u. Okay, x changes from 1 to 4. And u would change from, when x equals to 1. And that's going to be 3. 1x equals to 4. And that's going to be 2 plus 2, 4, 144. Okay? And then we're going to do our step 1, 2, 3. We're going to do our step 1, 2, 3. And let's go. Let's move forward. Okay? Lower limit change, so we're going to do the change of 1, 2, 3. 4 root, right? So the top is going to be root of u. Okay? And root x under dx, root x under dx, we put them together. And this whole thing is du, 2 times du, right? Is 2 times du. So 1, 2, 3 all modified. Okay? You can bring the 2 outside. And root u is just going to be here. You see, it's not a very complicated situation. Okay, so 2 antiderivative of root u is 1 over 1 plus half. I think we've done this many times. 1 plus half. Okay, u raised to the power of 3/2. No, sorry. U raised to the power of 3/2. Okay, the bar, lower limit, which is 3, upper limit, which is 4. And this piece here is going to be 3 over 2. So that's going to be 3 under 2 on top. So that's going to be 4 over 3. Okay, so that's going to be 4/3. And the rest is just substitution to do capital F of B minus capital F of A. So 4/3, I'm going to leave it out. Okay, u raised to the power of 3/2 minus 3/2, u to the power 3/2. So substitute u by 4, substitute u by 3. Almost done. Almost done. Okay, let's see what we get. Let's see what we get. 4 is equals to 2 squared. Okay, so this is 2 squared. And these two power multiply, we get 2 to the power 3. Right, we get 2 to the power 3, which is 8. Over here, well, it equals to 3 times root 3. Okay, because this is 3, this is 2 plus on the power 1/2. So this would make it 3 plus 3 multiply root 3, if you like to see it that way. But you can keep the original form. Okay, so near the end, in the end, this is just 8. That's it. That's it. You can use a bracket, or you can keep the bracket, or you can change it to parentheses. It doesn't make any difference. Just stop here. Okay, just stop here. Okay, just stop there. You don't need to go further. You do not need to go further. All right. Now we're gonna break it into 2 parts. Okay. Let's do 65. We're getting close to 1 hour. All right, so all right. So in this case, we're gonna have u equals to 1/x. Okay, so du equals to negative 1/x squared dx. Right, we have a dx over x squared already, so we will need that to be substituted. So dx x to the power over x squared equals to negative du. All right, and table. We got x, we got u, right? X from 1 to 2, u will be, we will get x equals to 1, u equals to 1, right? When x equals to 2, u equals to half. So now let's do 1, 2, 3 substitution. Substitution 1, 2, 3. Okay, lower limit, right? 1, 1. Upper limit 2, half. So upper limit is half. Okay, e to the power u. So e to the power of u. Okay, du over x squared, that's negative du. So that's negative du. 1, 2, 3, all substituted. 1, 2, 3, all substituted. But there's another thing. Remember, we have learned a property when we swap the upper limit and lower limit. Okay, I'm going to show you which property is that. Oops. There, this one. Okay. When we swap the limit a from a lower limit b, upper limit a, swap to lower limit a, upper limit b, we generate a negative sign. So if we swap 1/2 and 1, we will generate a negative sign. So this will be half. Upper limit will be 1, right? And the e to the power of u stays, and it will be generating another negative sign. So negative, negative makes positive. Okay? And then antiderivative, e to the power of u, bar, lower limit, which is a half, upper limit, which is 1. So equals to e minus e raised to the power of half. That is e minus root of e, square root of e. Okay, of course you can separate these words into these number of rows. All right, so step 1, 2, well, action 1, 2, 3 from all of x to all of u. Okay, all in u. Let's see, 66. Let's do 66. Maybe make this to be the, we'll see, I'm trying to make it to 1 hour. Okay, not too much more, not much longer than 1 hour. Okay, so in this case, we're going to assume that u equals to e to the power x, right? And the u equals to e to the power of x dx, right? We have a e to the power x times dx, and that makes du, right? So that's ready. Table. And we got x, u, right? X runs from 0 to 1, sorry. And u runs from x is 0, that's equals to 1. 1, x equals to 1, and that's just e. So let's do the change 1, 2, 3. Let's do the change 1, 2, 3. We can actually do it here, why not, right? So change 1, 2, 3. Lower limit now is 1. Upper limit is e. Okay. And inside e to the power x times dx, that's du. The denominator is 1 plus u squared. All right. Okay, that's arctan of u evaluated at lower limit 1, upper limit e equals to arctan of e minus arctan of 1. Arctan of 1, okay, arctan of 1 is equals to pi over 4. Okay, so this is pi over 4. So our final answer is just arctan of e minus pi over 4. That's done. That's finished. Okay, so let's do one more, which is 67, and then we're gonna wrap this up and we'll make another video. 67. Okay, 67. What about 67? 67 is a function, right? Right here. You may think of any way to substitute. You may think of any way to substitute. We also notice that this is an interval. The interval of integration is from negative pi over 4 to positive pi over 4. It's an interval that is centered at the origin, right? And after much effort, you will realize some of the most obvious substitution is not going to work. Okay, it's not going to work. So think of using symmetric function properties. Okay, so we'll be asking the integrand function f of x. Is this function even or odd? Okay, in fact, this function is odd. Why? So here's the reason. If we plug in f of negative x, every x will be substituted by, all the x will be substituted by negative x. Okay, negative x. And then what? We got negative x raised to the power 3, right? Plus negative x raised to the power 4 is the same as x raised to the power 4. X raised to the power 4. Tangent function is an odd function. So this is going to be tangent negative x is going to be negative tangent x. Okay. So at this point, we will get negative of this whole thing. We just factored out the negative sign. And that's equals to negative f of x. That's the definition of odd function. Okay, as an odd function, on an interval from negative a to positive a, the integral is 0. The integral is 0. Then you say because f is odd, why f is odd? We have demonstrated f is odd. Okay, that is the end of this lesson. We will have another one, okay? And thank you for watching.